Welcome to this demo of using ANSYS ICEM CFD 14.5 Interactive with a multi-body part. This basic example will show you how to use ICEM CFD Interactive and ICEM CFD Batch as part of the ANSYS Meshing component of a system such as static structural. Let's start by parameterizing the geometry so that we can update it later. Parameterizing a model is easy. You simply find a parameter that you want to change, such as this extrude depth, and you click this box to turn it into a parameter. So we can call this extrude depth. As soon as that's created, the parameter set bar is connected, and if you click on this you can see that there's now a parameter called extrude depth and it's set to 30. You can see now you can edit it here, but you can no longer edit it over here in Design Modeler. It's going to be grayed out for us. Now this model is just a simple circle. It's based on a simple sketch that's being extruded and then split, but it's been split into two separate bodies, and you can see this is a multi-body part. Next we enter ANSYS Mechanical so we can set up the model. Rather than use the default mesh that gets generated, we're going to choose one of the methods that allows us to use ICEM CFD Interactive. So I'm going to choose a method. Geometry selection, I'll pick both bodies, holding down the control key to select both, and apply. So now this automatic method is applied to both, but I want to change it from an automatic method to multi-zone, which is one of the ICEM CFD methods. It would also work if we went with the tetrahedrons patch independent. Under multi-zone you find options for write ICEM CFD files. If you simply said this to yes, it will just write the ICEM CFD files so that you could edit them later or load them later in ICEM CFD separately. But if you choose interactive, it actually launches ICEM CFD and lets you run from there. If you choose ICEM CFD batch, it lets you run the interactive replay script that you created last time. So we usually start with interactive and then we go into replay. So let's choose interactive now. And then one more option appears is the post operation or override method. Post operation means generate the mesh with the method and then load up the mesh files inside ICEM CFD. Override method means just set it up and then go to ICEM CFD and we'll generate the mesh later. But you'll see the blocking and all that will still appear in ICEM CFD. So now we say update, and ICEM CFD is launched and the model is loaded, and you can even see the blocking. If you turn on Premesh, you can see the Premesh is ready to go. So this is the default mesh that was generated for this particular model. Now if we wanted to, we can mess with this in ways such as go in here and adjust any edge parameter, blocking tab, Premesh, and adjust an edge parameter such as this one, and maybe we want to put in a lot of bias or something like that. Spacing 1, make it 0.5, copy parameters to parallel edges, and apply. So now we generate a new premesh. You can see this biasing that's happened. Now if this was the mesh that we wanted, we could send this back just by, well, you got to convert to unstructured mesh first. The unstructured mesh is what gets loaded and sucked back into Workbench. So now when I close this, it asks me if I want to save the project. Yes, please. And Workbench will load it. During the loading process, it actually makes sure that the incoming mesh fits to the geometry, so everything has to match. And it also checks for mesh quality and makes sure that everything passes the checks for the physics that are set. Now if I want to, I could actually try a whole new blocking. So to do that, I go back into the mesh. Let's actually clear it to make sure that we have cleared everything. This actually just clears the ICEM.uns file. It doesn't remove the replay file and those sorts of things. So I can say yes, and now we'll update again. So again, it's going to launch ICEM CFD. And again, brings in the model, brings in the pre-blocking, and we're back to where we were, back to this original mesh. Now if we wanted to, we could record a script where we do all sorts of different things, different types of mesh changes, all sorts of things that you can record in ICEM CFD. It doesn't have to be a hexa model, it could be a tetraprism or anything like that. But there are a few key things we need to do. We can't touch the geometry, we can't change any of these names, or it won't be able to go back and reconnect with or reassociate with Workbench. We can't add geometry, remove geometry, add curves, anything like that would cause problems. And if we delete the blocking, it's going to delete these volume materials. Let me show you those. Solid. So you can see that the one side, this is the other side. So I just make a quick mental note that the positive X side of this ring is created material _1, and the other side is created _ material. So we go up to File, Replay Scripts, and we want to load a script file. There is some bookkeeping that needs to get done to make sure that the replay file connects properly with Workbench. And rather than have you figure that all out, we include a default file here, a sample file. So just open the one that's in there already. Don't just start a new file or it won't work. And the sample replay file says this is a sample script for ICEM. It gives information about setting up working directories and all this stuff so that it can connect properly to Workbench so that it knows the actual name of the project file and all that sort of thing. And then it says, please add your scripting commands here. So just go and place your cursor there and make sure it's recording after current, and then you can just work from here. I'm just going to move this out of the way. So the first thing I usually want to do is unload this existing blocking. File blocking, close blocking. No, we don't need to save it. And you see that's the first thing that gets recorded in this script. And so we can also see here the names of the two material families that have now been removed, and we need to make sure that we add them back. So we go into blocking and we initialize blocks. We want to create a 3D bounding box around these entities. You don't need to select anything, it'll assume everything. Initialize with settings takes all the surface parameters with it, but the most important thing is to make sure that the material of this block matches what we saw before. So I'm going to call it CREATED underscore MATERIAL, just like we saw before. Apply. But now the entire block is in that created material. So let's split this blocking in half. You don't need to split it now, you could do it later, but might as well take care of it now. So split in ICEM, you just split, you can drag it to where you need to. I'm landing it approximately at the right spot, middle mouse button to accept. And now I've got two blocks, and I can create a new part. Create part, CREATED, material. And this option, select blocking material, pick this right-hand side block, middle mouse button to accept, and now we're at a good starting point for our split up. Materials are properly assigned, everything's using the right names, and we can just continue from here and block this model. Edge to curve. These three edges associate to this curve, and it's important that I didn't accidentally associate any of these edges to this curve, because then there would have been problems later when it tries to go back to ANSYS Meshing. And don't forget to take care of the curves along the interface. That has to be nice and crisp, otherwise the mesh will have problems associating back to the original geometry when it goes back to ANSYS Meshing. Snap fit, so everything jumps into place. And then if we want to, we could move things around right now. Move vertex. We could even try the option to move multiple vertices and drag them around if we wanted to try something like this. Now you don't need to move them, I'm just to show that things have been changed. And again, all of these steps are being recorded for us. So now the next step is to create the O-grid. So we go to split blocks, create O-grid, select the block. These two blocks, we can do it all at once. Select faces. And when you're happy with your selection, you can middle mouse button. Now when you create an O-grid, it comes in usually about 1/3 of the way. And since our ring is much thinner than that, and we would have to adjust it back again, it's easier just to say absolute. And the actual offset is 1 millimeter. So that's perfect already, and we hit apply. And we get our little O-grid. Now these central two blocks are not at all relevant to us, so we can delete them. This block and this block. And now they're gone. And now we can associate the rest of these edges. There's a hotkey for that, but P is project edge to curve. Grab the edges that you want to associate. Grab this curve. And again, don't forget to zoom in and take care of these edges here around this interface. Just because something aligns, it doesn't mean it's actually associated. You have to make sure that you actually associate the edges. Otherwise, ANSYS Meshing will not understand that those edges follow those curves in the geometry, and it'll have trouble reconnecting. Now another step you can do, it's not absolutely required. We could just take care of these by moving and just drag these into place. You just drag them past the ends and that kind of tucks them into place. But you might also want to take it the extra step and just associate all the vertices to points. Just make sure we have points. There they are. If you make a mistake, you can undo it. The undo is recorded in the commands. It makes the script a little less efficient, but it's okay. If you delete the mistake, make sure you're very careful about the bookkeeping there. On this side, I won't bother tucking them in. I'll just do the associate vertex to point, just to snap things into place. Alright, so now the model is pretty well set up. Let's set up the premesh parameters. And we'll just use this method to update all, which takes the sizes from the geometry which came from ANSYS Meshing. So you can actually set up meshing parameters in ANSYS Meshing, and those will be carried through to here. So I hit update all. That takes it in. You can see the information there. Turn on premesh. And so here's that mesh generated now from a bottom-up method instead of the multi-zone. Now again, we have control. We can go in and adjust this mesh. We could say that we want to split edge parameters here. We can keep it as hyperbolic, or we can change it to one of the many other methods. We'll set spacing 1 as 0.5, spacing 2 as 0.5, and apply that. And we can copy that to parallel edges. Apply that, and generate a new premesh. So now you see that distribution. And actually, instead of 14 nodes, let's say 15, so that we get a node right down the middle of our ring. And now you can see these bunching display here is a little off from the mesh. If we recompute our mesh, now it's right on. We can set up also something along this direction. Maybe we want 3 elements through our thickness. So we set this to 4. Apply, recompute the premesh again. Now, if you want to, the replay script has been recording all of this mess. So we could go back and we could clean this up and only keep the last edge settings rather than all those various changes with the 14 and the 15 and all those sorts of things. You can see them up in here. All these different create mesh instances will slow you down, so we could delete those. Just hit delete one and it gets removed. You just have to be a little bit careful that you don't accidentally delete the wrong thing. If you don't know what you're doing, just don't do it. Here's another create mesh. We can delete that one. Here's the mesh with 14 nodes. We know that the 15 one is better, so we might just want to keep just the last one. So we can say delete this and delete even this one because there's another one coming down later. And you can see which edges point talking about because of this 101 to 102, and then this one has the copy to parallel included. So you can go through and you can pick these out. You can see all these undo, redo commands. There's an option that you can filter commands also, but we're gonna I'm not going to worry about all that right now. One important thing not to forget is you have to convert to an unstructured mesh at the end, and it has to be part of the replay file. So we right and click in here, convert to unstructured mesh, and we get our hex.uns domain loaded. There, turn off the premesh so you can make sure that this is an actual unstructured mesh. And it's the unstructured mesh that goes back to ANSYS Meshing, not the blocking file. So you have to make sure you make that step. The replay window is still open. I'm not going to kill it separately. I'm just going to close the outer window. And the first thing it tries to do is protect this replay file. It'll say save it. Yeah, we'll save it over the original. Do you want to replace it? Yes, please. Save the current project first? Yes, because saving this project makes sure that we keep all the UNS files ready so they can be loaded back in. It's just a double save. And then you see it finishes its work here. It's doing checking, making sure that all those parts are connected properly, that all the elements are on the correct surfaces, that it also does mesh quality checks and make sure everything is good. And there you go. So now I've got the mesh in here, and you can do lots of other fun stuff. I could go down here and say that I want to turn on, under equivalent stress, for instance. I could go down here and check this option to make sure that we have a max equivalent stress as an output parameter. And the moment I check that box, back here you can see the connects to the parameter set bar on the outgoing side. So now I've got an incoming parameter for the geometry size and an outgoing one for the max stress. I can look in here and see the equivalent stress maximum ready to be solved. If I can change this, I could get a new update. Meanwhile, back here, let's solve this. And you can see that it's solved with the mesh. Now, if I want to start using Design Explorer studies, if I want to go in here and drag and drop a direct optimization system onto this parameter set bar so that I could somehow optimize this geometry for minimum stress or something like that, I would need to be updating my geometry and the mesh would need to regenerate. And the moment it did that, it would go back and relaunch ICEM CFD Interactive because it would follow this tree. So what I need to do is make sure that that switch happens to turn this from interactive into batch mode so that it runs ICEM CFD in batch instead of an interactive from now on. So we've already set up the script is sitting there ready to go. We just want to make sure that we use that script and we don't actually launch ICEM every time. The only downside at the moment, as soon as you make that change, it sees it as a change underneath this branch and this branch goes out of date and you actually have to update this branch. Now when you do it, it's like a good way to check and make sure that your batch scripts are all set up correctly. So I hit update here. Goes and it runs ICEM CFD in batch mode this time. Since nothing's changed, it'll give us the same mesh as last time. But it does have to regenerate the mesh. Okay, so here's my mesh. Everything's regenerated. This tree is up to date. Everything down here is a little out of date, but we can solve that as well, just to make sure that everything's working now. And there we have a nice solved solution, deformation, stress. We can get a parameter of deformation as well if we wanted to. There's our maximum deformation. And then we go back to the project page. So now what we can do inside under the project page, we could try a number of design points. So if this is 30, that's one thing, but what if this is 25? Or what if this is 35? We could try those. They're not solved yet, so it's waiting, but we can say update all design points. And it is now running ICEM CFD in the background to generate the correct meshes based on the geometry changes that I asked for. And then it will solve, give us equivalent stresses, total deformation, and all of those sorts of things. You can see here that now the slight changes as we adjust our sizes. There you go, 3 different solutions based on that one blocking file being run interactively through ANSYS Static Structural. So let's review. The key things for making sure that ICEM CFD Interactive works. It needs to not change the geometry. If it changes the geometry, it has trouble reassociating and reattaching back to ANSYS Meshing. All of the edges have to be lined up properly. You have to maintain the right material names. If it created materials, you have to make sure you use those same names. Changing names causes problems. So don't change the geometry. Make sure that when you run your replay script, that you load the sample script that they give you so that you can make sure that you fit in with the overall process, the file names are tracked, and all those things. Make sure that the last step includes generating the mesh as part of the replay script so that will be generated every time. The unstructured mesh is what goes back to ANSYS Meshing, and then it gets sucked back, checked and everything, and then you make sure you switch to batch mode and run a recompute to make sure that it's all set up and ready to go. Alright? And that's all there is to it.